Welcome to Summarize Science. Today, we're diving into a fascinating study that puts the reasoning abilities of today's top AI models to the test. Researchers evaluated 15 different foundation models, which are the core engines behind tools like ChatGPT. They tested them on 79 complex problems from 8 different fields, including physics, calculus, and economics. And they ran these tests across 3 completely different computer systems: a world-class supercomputer, a commercial cloud platform, and a standard university server. The first bombshell finding is what they call the parameter efficiency paradox. It turns out that bigger isn't always better. A 70 billion parameter model named Hermes actually achieved the highest score, beating its own much larger 405 billion parameter version. This suggests that simply making an AI bigger doesn't automatically make it smarter at reasoning. Instead, the quality of the data it's trained on might be far more important. The second major discovery was a trade-off between getting the answer right and showing a logical process. One model, DeepSeek R1, was incredible at explaining its reasoning step by step, but then often got the final answer wrong. Meanwhile, other models were great at getting the right answer, but their reasoning steps were often disconnected, like they were taking a shortcut without genuine understanding. This creates a dilemma. Do you want an AI that's transparent and can teach you, or one that's a black box but reliably correct? Interestingly, the study found that over time, AIs have gotten dramatically better at certain subjects like calculus. However, nearly all models, regardless of size or age, consistently struggled with optimization problems, showing it's a universal challenge for modern AI. Perhaps the most important finding for science is that the computer hardware didn't matter. A model's reasoning performance was almost identical whether it was run on a supercomputer or a university cluster, with less than a 3% variance. This is fantastic news, as it means researchers everywhere can conduct this kind of vital testing without needing access to billion-dollar machines. The study also looked at models with different brains, not just the standard transformer architecture. A state space model called Falcon Mamba performed competitively and was the most consistent of all, meaning its answers were highly stable and reliable. So let's recap the key takeaways from this massive experiment. First, making AI bigger doesn't guarantee it will be better at reasoning. Data quality is king. Second, there's a fundamental conflict in current AI between explaining the reasoning process and arriving at the correct answer. And third, these evaluations are robust and reproducible, democratizing AI research for scientists everywhere. These findings suggest the future of AI progress will come from smarter training and architectural diversity, not just from building ever larger models. Thanks for watching Summarize Science.